Welcome. This presentation is about a plot at Lockwood Farm where we're using nanoparticles of metal oxides to suppress diseases of plants. This particular study was conducted by me, Wade Elmer, Ms. Renata Piera, Dr. Chung Sung, Dr. Jason White, and we've been assisted by my technician, Mr. Peter Thield. So what is a nanoparticle, and how big is a nanoparticle? Well, by definition, any particle that has a diameter less than 100 nanometers can be considered to be a nanoparticle. Now, how big is that? Well, if the Earth were to be considered as a particle, a soccer ball would be in the range of being a nanoparticle. So it's very small. And when particles are at that size, their properties change. Their surface area is tremendous, so they're able to dissolve and release their product much faster than in the larger form. Also, nanoparticles, being so small, are able to travel into plant tissues faster than their larger forms. So it becomes a nice delivery mechanism for delivering micronutrients to various parts of a plant. Now, micronutrients, as you know, are nutrients that are in very, very small amounts. And many of the micronutrients that plants need are metals like copper, manganese, and zinc. And many of these products can be applied as nanoparticles, usually as metal oxides. Now, micronutrients are very important in plants because they can protect the plant from disease and stress. And when these nanometal oxides are applied to the foliage of very young plants, they grow larger, they have less disease, and they frequently have more yield. Now, we have shown that on eggplants, tomatoes, and watermelon, that nanoparticles of copper were able to suppress the root diseases. And in many situations, we were able to see increases in yield following a single application of the nanoparticles to a very young plant at the beginning of the season. So we wanted to know whether or not we could use a larger grain crop like soybeans with nanoparticles to see whether or not we could suppress some important diseases on soybeans. Now, soybeans are susceptible to a root disease caused by Fusarium virgiliforme, and this disease is known as soybean sudden death. This disease causes millions of dollars of losses each year, and there are no highly effective strategies for suppressing it in all areas. So in our studies here, we took young seedlings and we dipped them into nanoparticles of copper and or zinc. We looked at some combinations, and then we planted these plants into disease-infested soils. Now, when we measure soybean sudden death disease severity, in the greenhouse, we generally look at the amount of root rot on the roots. So in this graph we see here, the larger the bar, the more disease. So in the control plants, those that received no nanoparticles, we had about 43% disease in those plants. And as we added copper, zinc, or we combined it at 500 ppm, and that's 250 of copper, 250 of zinc combined, and then at the higher rate where we combined both of them at 500 ppm to give us 1000 ppm, we were able to get much more disease suppression. In fact, a 63% reduction was observed in this study when we put copper and zinc together. On your right, you can see some young seedlings about 10 days after they were treated with these suspensions. You can already see the increase in growth and the extension of the stem elongation. So in June 5th of this year, we put out plots at Lockwood Farm to study this disease again in the field. Here we're going to be looking at growth, yield, and disease. So this will give us a lot more information. It will be a lot more applicable to growers if we can show that the nanoparticles do increase the yield and suppress the disease. So with that, I'll be glad to answer any questions. You can see me here at the Agricultural Experiment Station. You can email me at wade.elmer@ct.gov, or you can give me a call, and I'll get back to you as soon as I can. Thank you.